the recording as well. Okay, so this is what we were doing last time. We were really doing an example, right?
Yes.
And yeah, so let's come back to that particular example.
Yes, sir.
Now, we'll start the example. I'll try to tell you what was the problem from the beginning because the class ended last time. Anyways, so it was this thing that we had a train, and this train was traveling around along this circular path, right? Following this
Yes.
circular trajectory,
Yes.
and we were given the circumference of this track as 2.4 meters. So this means that this path, every so if it travels all over this path, it will cover a distance of 2.4 meters if it comes back to this point
Yes.
A, right? So we're given that this train covers this entire circumference in some time, which is 4.8 seconds. So the train covers the entire distance of 2.4 meters in 4.8 seconds. So
Yes.
first, let's try to compute. Our goal was to understand difference between speed and velocity. So first, let's compute the average speed of this problem, really. So how would you compute the average speed in this case? We
Average
know
speed
that, yeah,
formula.
yeah. So speed is given as any distance. In this case, the distance that this train is going to cover is 2.4 meters,
A
right? It's
pound.
covering 2.4 meters,
Yes.
right?
Pound time.
And yeah, so it's covering that distance in 4.8
4.5 seconds.
seconds,
Sir,
right?
the standard at the SI unit for time is seconds or minutes?
It's seconds. The SI unit for time is seconds. So I'll also write that quickly over here. So length or any distance, the units, SI units are meters. For time, the SI units are seconds. And for mass, the SI units are kilograms. These are some of the very important dimensions, right? I mean, quantities, M, L, and T. So it's written as capital M, because you can make a lot of quantities using only these three physical quantities. So just
Yes.
remember that these are the SI units for all of these, right?
Okay.
Okay. So if I do this thing, it will give me 1/2 meters per second, which is 0.5 meters per second. Now that was very simple, right? We just had a formula, we put some values in it, and we got the answer. So the average speed is 0.5 meters per second. So every second that passes, the toy train travels
It
0.5
covers.
meters.
Yes.
Yeah,
It
it covers
covers.
0.5 meters. Exactly. Now, so what about velocity?
It will also have a
Oh,
formula.
yeah. So we know that velocity is defined as change in displacement, right? So it
Yes.
is displacement divided by the time it takes to complete that displacement. But what would be the displacement in this case?
Displacement would be like this 0.5.
That was the speed, right?
Yeah, that was the speed.
Displacement was what? Yeah. So displacement
Displacement.
was it was the
It could
distance,
be times time velocity.
right? Okay, but I'm not looking for a formula at this point. I'm trying to understand. I want you to tell me the concept of displacement. What was displacement? It was
Displacement.
defined as the shortest
Yes.
distance between
Covered
2 points,
between two
right?
points. Yeah.
Yeah, exactly. So the 2 points over here are starting from A and
And
ending
ending at
at
it.
A. So what is the
Yes.
shortest distance between the first and the second point, initial and the final point?
It is the same, I think.
It is the same point, right? So the distance
Yes.
is between
distance
these two
is
points,
yes, distance between the point is displacement.
right? But it is what in this case? It's zero,
It
right?
is,
Because
yeah, it is zero. There
yeah,
is no,
because
yeah, there is no displacement. It started and
there
ended at the same point.
Exactly. So that's what I was looking for, right?
I know.
So that was the trick that you're supposed to understand, that in this case, there is some speed, of course, but the velocity is going to be 0, right? Because displacement is 0 meters, and whatever time it is, well, it's 4.8 seconds, but it doesn't matter because 0 divided by anything is just 0. So really, the velocity would not be there in this problem. So the velocity of this train is 0 because of the direction, right? Because if I tell you what I told you in the last class as well, in velocity it is a vector. So at every point, if I on this circle start drawing a vector for velocity, at every point I keep drawing a tangent vector, right? So like this, and then the tangent vector is like this, and then over here it's like this, and then here the tangent is like this. So I keep drawing these tangent vectors. All of these tangent vectors would sum to 0, because you can see that the opposite of this is over here. So if I add these two vectors, I get 0. The opposite of this is over here. So these two vectors are opposite. So if I add all these vectors, I'll in total get 0, right? And that I told you yesterday as well, that is always the case if we start and end our journey at the same point, right? So is that clear? Do you understand why the displacement would be 0 for this case? I think
Yes,
you're,
sir. Yes, I have
yeah,
been speaking something, but I thought it was mute. Yes, I
yeah, no,
understood it.
it's okay, no problem. Okay, okay, great, great, great. All right, so that was this problem, and the main goal for this problem was for you to understand the difference between speed and velocity. So
Yeah.
we can now move on, and let's try to do another problem. And
Okay, sir.
let me, okay, so here we have this thing. All right, so let's suppose that you have a car. Okay, there's a car, and this car is traveling on a road, and the road is straight. So this is my road, and the car travels on this road in this direction. Now let's suppose that the distance from the car to this point, this line that you can see, this distance is 840 meters,
Okay.
right? Okay. Now we say that the car is moving at some constant speed. So let's suppose that the velocity of this car is 35 meters per second to the right. Now, when it moves this distance, 840 meters, at a point, it's going to apply brake. So the driver in the car is going to apply brakes. What would happen when the driver apply brakes? The car starts slowing down, right?
Yes.
The car will start slowing down as soon as the driver applies brakes. And so the purpose of the brakes is to produce negative acceleration or deceleration. It will slow down the car, the brakes. So we say that the car apply brakes at some point, and after the driver applies the brakes, after brakes are applied, the car comes to rest after time, let's say 7.0 seconds. After the brakes were applied, 7 seconds pass, and then the car stops completely. So after 7 seconds, the velocity completely goes to 0, right? So that's what it means, right? So if the car completely stops, that means the velocity would be 0. So the question is, first of all, let's try to find the time. So let's first find the time for which the car moves at constant speed. So we need to figure out for how long the car was moving at a constant speed, which means we want to find out the time before the brakes were applied. From this starting position to the position before the brakes are applied, because the brakes are applied at this point after 840 meters. This is the point where the brakes are applied. So as soon as the driver pushes the brake, the car will not be moving at a constant speed anymore, because when the brakes are applied, it will start slowing down the speed. So speed is no more a constant. So we want to find out the time from this position to this position, just before he applies the brake. How long will the car travel before the brakes were applied? So we know that the distance before the brakes are applied is 840 meters. So that's the distance or displacement, which is 840 meters before brakes are applied. And the velocity of the car is constant before the brakes are applied, right? So the velocity of the car is also 35 meters per second. Before all of this is before the brakes are applied. So I know and I need to find out the time for how long it will maintain this speed 35 meters per second. So I know an equation which
Yes.
relates velocity, displacement, and time, and that is velocity is equal to displacement divided by time. Now I need to find out time, so I'll rearrange this expression for time as t equals, I'll bring this t over there and v over here, so that's s by v. Now I know everything, I'll just put in the values. So the displacement before the brakes are applied is 840 meters. The velocity before the brakes are applied is a constant velocity of 35 meters per second. So this becomes, if I do the math, it becomes 24 seconds. So this time, t equals 24 seconds, is that particular time for which the velocity of 35 meters per second is maintained. So before the brakes are applied, you understand that as soon as I apply the brakes, the velocity will start changing. Before that, the velocity was this constant value, or at every point until the brakes are applied, it was 35 meters per second. So that's the reason when I used this velocity and this distance, I got a value for time, which is from this position of the car up until this point when the brakes were applied. And that was the question. We were supposed to find the time for which the car was moving at a constant speed. So just before the brakes were applied, the car had a constant speed as well. So is that clear? Okay, I think you might be muted. Yes, you are muted. If you're saying anything, I cannot hear you. Is it clear? All right, so I'll assume that you understand. And let's move to the second point, or just the second part of this problem. The next thing, let's try to find out the acceleration of this car as soon as the brakes are applied. Because when the brakes are applied, it will produce a negative acceleration, right? Because it has to slow down the car. The brakes are going to slow down the car. So the next thing is I want to figure out the acceleration of the car when brakes are applied. So how do I do that? I need because I know that as soon as the brakes are applied, the car starts slowing down. So we know that eventually at one point the car is going to come to a stop or come to rest, which means that the velocity would be 0. Now I know that acceleration is change in velocity divided by time. Now, what is the velocity before? We know that the velocity before, we know that it is traveling at a constant speed of 35 meters per second. That was the speed that the car is initially traveling at. And when at some point the car is going to come to a stop because of the brakes, which are producing deceleration or negative acceleration. So the final velocity of the car is 0 meters per second, right? So the acceleration would be the change in velocity, which would be 0 minus 35. So the final value minus the initial value, that's the change, divided by the time it takes, which is 7 seconds. Why? Because in the question, it says at some after 7 seconds of the brakes when they were applied, the car came to a stop. So the time it takes for the car to stop after the brakes are applied is 7 seconds. So in place of time, we'll put 7 seconds. And this is meters per second. And so this would give you minus 35 over 7 is minus 5.0 meters per second squared. So that is the acceleration of the car after the brakes are applied. So which means this thing really is telling you that, first of all, you see this negative sign over here. This negative sign tells you that the velocity is decreasing. This means, remember, acceleration was defined as the change in velocity per unit time, right? Per unit time. So this result, minus 5.0 meters per second square, means that the car will slow down every 5 meters per second would be cut off from the speed of the car as every second pass. So if I come back to this diagram, as soon as the brakes were applied, after every 1 second that would pass, the velocity of the car would start decreasing by 5 meters per second. So at this point, if it was 35 meters per second, after 1 second, it would be 30 meters per second. And after 2 seconds, it would be 25 meters per second, and so on. So it would take 7 seconds to reach 0 meters per second. And so the car would eventually then come to a stop. So is that clear?
Yes, sir, it is clear.
Okay, wonderful. So now let's move on to the next topic of our discussion, which is graphs. So let me write the heading down. We have this topic of graphs. Now, really, we have multiple types of graphs as well. One of the types is, okay, so we are running out of time, it says over here. I don't know how much time do we have left, but anyways. So first of all, what is a graph? A graph is really, it's just a visual picture of what is happening, right? So you can imagine this situation by looking at a graph. So you can have multiple types of graphs. You can have displacement versus time. So that would tell you how the value of displacement changes as time progresses. You can have velocity time graph, which shows you how velocity would change as time progresses. So really what's happening in a graph is that it is relating two variables. Now, if you are just a mathematician and you don't know about physics, or you don't really care about physics, then you would just say that I have a vertical axis and I have a horizontal axis on a graph, and then you'll just assign any variable to it. It doesn't matter, any variable. You can say that this is X and this is Y. Now these are your axes of the graphs, right? So this is the horizontal axis and this is the vertical axis. It doesn't matter what you call these axes. You can label it as X, you could have labeled it as L, M, N, O, whatever, right? So any alphabet, whatever you want to name it, you can name it. There's nothing special about X and Y. That's the first thing. But now if you're doing physics, if you want to see a relationship between two physical quantities, then we, for example, normally we tend to put time on this horizontal axis. And we put the quantity that we want to see how that quantity will change as I change time. That quantity is placed on the y-axis. Now I can have graphs of multiple shapes. One of the shapes could be something like a straight line like this. Then you could have something that looks like this. You could also have something which looks like this. And these are just some random shapes that I'm drawing, right? So my point is that the graph could be a curve, it could be a straight line, it could be a line which is completely parallel to the x-axis, it could also be a line which is completely parallel to the y-axis, or it could also be any type of curve, right? So these are different shapes of the graphs. Now, do you understand the basic idea of just a graph, just the
Yes,
definition
sir.
of a
I
graph?
understood.
Right. Okay, great. So that's now we can talk in terms of physics. We can start talking about a graph which is known as the displacement
Sir, one
time
minute,
graph.
sir. Just 1 minute. Can we just
Sorry,
like repeat? Can we have just like have a quick review about each line? Just a quick one.
about the graphs.
Yes, just a quick one. You know, it is all mixed up in my mind, so I just want a quick review in that, so it will
Oh,
be
okay, no
done.
problem, no problem. So basically I started with graphs, right? And I explained what do we really mean by a graph. uh,
Yes.
Graph is really just a visual picture of understanding how any of my variables are going to behave. So if you want to understand the behavior of any two variables, we can use a graphical representation, really. So, and that representation can be in this form of, first of all, we have axes, y and x. These are axes. Now, it doesn't matter if I call this x-axis or z-axis, l-axis, m-axis. You can give it whatever name you like. It doesn't matter. There's nothing
Okay.
special about x and y.
Okay.
Now, these are your two axes. Note that these two axes are chosen so that they are perpendicular to each other. So the angle between the two axes is 90 degrees, which tells you that there is no part of x in y and there is no part of y in x. That means that x and y are completely independent of each other. Now, we can have multiple types of graphs. It could be a straight line like this. It could be a straight line which is parallel to the x-axis. It could be a straight line which is parallel to the y-axis, it could be curved as well. And these lines are actually a relationship between x and y. So these lines are known as relationship between x and y. So these
Yes.
two quantities. Now, in physics, normally we tend to put time on x-axis, and whatever quantity that we want to see that would be changing as time progresses, that is placed on the y-axis. So this would be more clear now when we are
Yes,
discussing
sir.
this displacement time graph. So moving on to the displacement time graph, is that clear now? Is the
Yes,
idea
sir.
of
Sir,
graphs
yes,
clear?
idea about the graph is clear, but what about these lines, like the purple one, the green one, the red one, and the yellow line?
Oh, yes,
What
of
are?
course, of course. Right. So these lines, I just drew them randomly. We will see what do the lines mean when I assign a physical quantity to this x-axis and to y-axis, which is what I'm going to do in this displacement
Okay,
time
okay,
graph,
okay, okay.
right? So these lines are just there in general. They could be anything.
Okay.
Normally, it means that this straight line that you see, this one,
Yes.
this
Yes.
line just tells you that the ratio of x and y